Hey everyone, in this video we're going to be talking about experiments, and they are found in the last part of Module 6 if you're following along in your reading. Okay, so we've been looking at this graphic organizer for the past week and a half, and it starts off with us asking a question about human behavior and mental processes. Then we use one of these descriptive methods, or two or three of them, and we gather as much data as we can about our topic. Once we do that, we figure out, are there two variables that we think might be related? If there are, then we conduct a correlational study to see if there's a relationship. If we find a relationship, we can't unfortunately prove causation within correlation, which we talked about today. So we have to do the last research method, which is an experiment. This is the only research method that can prove causation. So what you do first is you decide on your independent and dependent variable. These could be the exact same independent and dependent variables that you guys had for your correlation studies. So maybe I think that caffeine consumption was related to your test scores, and I found that there was a relationship, and so now I want to actually test it in an experiment to see if there's causation. So first I need to choose my independent variable. This is the thing that I'm going to be manipulating in the experiment. And in this case, it'll be the caffeine, because I'm going to decide who gets caffeine and who doesn't, and I'm going to measure their test scores. Therefore, the test scores are the dependent variable. They are dependent on the independent variable, which is the caffeine. A good way to help yourself out with this is that if it's an if-then statement, whatever follows the if is the independent variable, and whatever follows the then is the dependent variable. So my hypothesis might be, if half of my students drink caffeine before every test, then their test scores will improve 20% over the control group. That could be my hypothesis. So to test yourself, I want you to read this statistically significant study right now, and I want you to see if you can determine what is the independent and dependent variable. And so hopefully you were able to come up with the conclusion that participation in the study program is the independent variable, and then the graduation rate is the dependent variable. So the graduation rate is what they're measuring, and then whether or not they're in the program is the independent variable. So next, just like in our correlation study, we have to create operational definitions, which you already know how to do, so that this study, this experiment that we're doing can be replicated. Next, you randomly assign participants. It's very important not to get confused with random selection here or random sampling here. So if you're surveying, you're going to get a random sample or a random selection. Okay, you're going to pass that survey out to a bunch of different people randomly. But randomly assigning means you have your sample already, you have your group of people that are going to be in the experiment, and now you're randomly assigning them to either the control group or the experimental group. And again, it has to be random. It could be like you list their names out in alphabetical order, every fifth person goes to the control, every other person goes to the experimental. So the two groups are, like I said, the experimental group. This is the group that's actually going to be getting the independent variable. So in our case, it's caffeine. I'm going to be giving them pills that have caffeine in them to see if they impact their test. The other half of my group is going to be the control group. They are also going to be getting pills, but they have zero caffeine in it. It's all sugar. It's a placebo. There are also two types of research studies that occur within experiments. You have the single blind and you have the double blind. The single blind means that the researcher knows which person is in the control group and which person is in the experimental group. The double blind, which is the better research method to prevent researcher bias, is when the researcher doesn't even know who's in the experimental and who's in the control group. And you might ask, well, if the researcher doesn't know who's in each group, who knows? How is he able to tell? Well, usually what they'll do is they'll hire outside contracting companies that will randomly assign the participants for them, and they won't get the results until after the experiment has been completed. Now, a lot of times when you do experiments, what happens is this thing called the placebo effect, which hopefully some of you have heard before. The placebo effect is when someone who is not taking the drug or the independent variable ends up experiencing the same effects as if they were taking the drug or the independent variable. So in our case, if somebody that I had on the sugar pill that wasn't actually taking caffeine started exhibiting symptoms that they were on caffeine, they were very energetic, very focused, then that would be the placebo effect, even if they weren't on any caffeine. This happens all the time in a lot of different types of situations. People that are depressed and seek out counseling will actually start to feel better, not necessarily because of the counseling, but just for the mere placebo effect of they know they're trying to go get help and their body thinks they're getting help. So the placebo effect is something that I'm extremely interested in and I love to play with. So we are going to be looking at this more in depth in class tomorrow, but at least this gives you an idea of what it is. Things to worry about in an experiment. Just like in your correlation study, you have those confounding third variables that might be impacting your results other than just your independent variable. So if I'm measuring test scores, other confounding variables could be that, just pure intelligence level of the student. It could be the time of day that I'm giving the test. It could be what the student ate the night before, how many hours of sleep they got the night before. All of those things could confound my experimental data. Experimenter bias is also something that you want to make sure you watch out for in experiments. This is why we do a double-blind experiment so that the researcher can't really put in much of their bias. And then lastly, demand characteristics. And demand characteristics are when the participants themselves kind of have an idea about what's going on, and they'll kind of play into the experiment a little bit, suggesting how they'll respond. So for example, if I know that this experiment is about how I do on tests after my caffeine consumption, then I might actually try a little harder on my test because I want to prove the theory right. Or I know they're trying to measure the effects of caffeine, so I'm really going to I'll do it a little differently than if I wouldn't have known really what was being measured. So here's just an example, something in the news today a lot is, which is better, breast milk or bottle feeding, or is there a difference? And so if we really wanted to tell the difference, we'd have to set up an experiment. First, randomly assigning mothers to two different groups, breastfeeding or bottle feeding. The experimental condition, those would be the babies that get the breast milk. The control group would be the babies that get formula. And then the dependent variable, we would measure their intelligence score at age 8. And that could tell us which is better. Now again, that's 8 years of a lot of confounding variables, but that would be the steps of an experiment. Well, there you have it. That was the quick rundown of experiments, and make sure you check out the last part of Module 6 in case you had some trouble understanding this stuff. And hopefully it's all review, but tomorrow in class we're going to go over this stuff and do some practice experiments to make sure you can apply all the terms we covered today. We'll see you tomorrow.